All right, so today we are going to be talking about ratio tables. So remember that a ratio is, a ratio table, sorry, is a way to compare quantities. So in this problem, it says Todd earns $3 for every 5 chores he completes on his chore chart. Find equivalent ratios using the table below. So if he completes 5 chores, he gets $3. So I could write that as a ratio of 5 to 3. All right, so if he does another 5, meaning he's done up to 10 chores, then he's earned $6. So that would be 10 to 6. Now the thing is, 10 to 6 can simplify. So if I simplify and divide both of them by 2, I get back to 5 to 3. Because it's still the same relationship, it's just happening more than once. So I can continue doing the same thing. So if they do another 5 chores, they get another $3, another 5 chores, an extra $3, and so on. So every time it's changing by 5 for the chores and by 3 for the amount of money. The most important thing is that we realize that it's still giving us the same simplified ratio of 5 to 3. So no matter what, now if it doesn't, then we have done something wrong because it should still be that same relationship. All right, so then it asks some questions about this. So it says, how are the number of chores and the amount of money earned related? So it's for every 5 chores, they earn $3. All right, so how are the values in the chores column related? So they're asking, how is that changing? So they're changing by 5. All right, so how are the numbers in the money column related? So they are changing by 3. So if I look at the ratio column, so I'm looking over here, what we should have noticed is that they all simplify, so all ratios simplify to 5 to 3, because that's how the chores were changing and how the total was changing. So I want you to pause for a second. I want you to try this next problem on your own and then unpause it so that you can check your work. All right, so this one's weird because it has some decimals in it, but it really doesn't change it. So we have 1 to 1.5 because it's saying there's 1 cup of cake mix, or pancake mix, sorry, to 1.5 cups of water. So if I double that and I do 2 cups, then I have to double 1.5 as well, which would give me 3, but that simplifies to 1 and 1.5. All right, so remember, it still simplifies to that. All right, so if I took my original ones here and I multiplied them by 3, 1 times 3 is 3, 1.5 times 3 is actually 4.5, so it still gives me that same ratio. And same thing with the 4 to 6. All right, so it says how many cups of pancake mix will be needed if there are 15 cups of water? All right, so if I kept going and I got to 15, all right, so the easiest way to do this is to say, what times 1.5 would give us 15? Well, I needed to just move the decimal, so really that's multiplying it by 10. And I could continue my chart if I had to, like I could do it that way. But if I do it by 10, then I would also take the number of cups of pancake mix and multiply it by 10. And that'll give me that I need 10 cups of pancake mix. Right? So again, you could have just continued the pattern. So if I did 1 times 5, 1.5 times 5, that would give me 7.5. And I could keep doing that if I wanted to. The other option is just to keep adding 1.5 here every time I add 1 here. So that's another way to look at it. So that kind of brings us to next piece here. So ratio tables are both additive, meaning you could just add to get to the next piece, and multiplicative, meaning you could multiply to get to the next piece. So it just kind of depends on how you look at it. So for example, I could look at it this way, as each time I'm going down here, I'm adding 2. All right. But if I looked at it as the relationship between the columns, technically to go from 2 to 3, what I'm doing is I'm multiplying that by some value. In this case, it's 1.5. And that's true for each of these. So it just kind of depends on how you look at it. All right. And again, it can still simplify to give you that same relationship as long as you did everything correctly. All right, so for these questions down here at the bottom, so it says a cookie recipe calls for 3 eggs for every 2 dozen cookies. So I would need 3 eggs for 2 dozen, meaning if I made double that, then that would be 6 eggs for 4 dozen. I'd do it again. So if I add another one of these, that would be 9 for 6. So each time here, I'm adding 3. Each time here, I'm adding 2. And so on and so on. So if I add 3 again on the top, and if I add 2 again on the bottom. All right, so if I wanted to figure out how many eggs for 60 dozen cookies, there's a bunch of different ways you could do this, okay? If you notice, I have 60 dozen cookies. So I have 6 cookies right here. Well, if it's 9 to 6, where the 9 is the eggs and the 6 is the cookies, well, if I want 60 dozen cookies, if I multiply these both by 10, that's going to give me 90 eggs for 60 cookies. So that'll work. I could also continue my pattern until I got there, but that's going to take me a while. All right, so then it says how many cookies can be made with 12 eggs? Well, if you look at our table right here, we have 12 eggs, and it says 8 dozen cookies. All right, so on this one, it says the developer earns $6 for every 21 apps downloaded. So for 21 apps, they get $6. So if they make another 21, that would be 42. Then they've earned $12. They do another 21, that will give them 63. That'll give them another $6, which would be 18. And then they do another 21, that would be 84. And they'll get another 6, so that'll be 24. All right, so then it says, how many apps would I need to do in order to earn $84? All right, so there's a bunch of different ways you could do this. Again, I'm going to do it differently than this one just so you can see it. All right, so if I want $84, well, if each time I'm getting $6, well, 84 divided by 6 is 14. So it's saying I'd have to do this 14 times in order to get to 84 here at the end. So if I take the number of apps times that 14, I'm going to get 294. So I would have to make 294 apps downloaded in order for me to make those $84. All right, so then it says how much money will the developer earn when 105 apps are downloaded. So if I take 105, now I get money for each of the 21. So if I do 105 divided by 21, I'm going to get 5. Well, that means it's 5 times that I'm getting paid $6. So 5 times that I'm getting $6, which would be $30 total. So it happens to be actually the next row in this, or next column in this. It'd be 105 and 30. All right, so then the last piece here talks about the relationship between the number of babies to the number of nursery workers. So we have a table. So it's asking the ratio of babies to nursery workers. Well, if you look at the first row right here, we have 5 to 2, meaning there's 5 babies for every 2 workers. We could simplify that, or we want to check that if we can, we can't. So we're going to leave it like that. So how many nursery workers are required if there are 35 babies? Well, if there's 5 to 2, in order to get to 35, I would have to multiply by 7. So if I multiply the 2 by 7, I get 14. So that's saying if I had 35 babies, I should need 14 workers. We actually do the same thing when we do like field trips. We have to have a certain ratio of students to teachers. And we do the same thing. We figure out how many kids we want to allow to go, and then we need to make sure we have enough chaperones. All right, so if 7 nursery workers are available, then what is the maximum number of babies they can accept? Okay, so this one is a little bit harder because 7 would be in between here. All right, so we're actually multiplying by something that's not a whole number, so that's a little bit harder. So since it's in between, what I would suggest you do is you figure out how many it is for each one, which I know is a little weird. Basically, think of it this way. If I have 7, but it's going by 2s, if I divide the 7 worker by the 2s that it's counting by, I actually get 3.5, which means I would actually be taking 2 times 3.5 to get to 7. So I'm going to do the same thing for the number of babies. I'm going to take the number of babies that were our basic ratio and multiply it by 3.5. Now, when I do that, I'm actually going to get a decimal, and, you know, it kind of doesn't make sense. So I got 17.5. What this is saying is that I have half a baby here. You know, we're not dealing with half babies. So the maximum number that they could take is actually 17. Because we're not able to take another full child. And we're not going to cut a baby in half. That's just gruesome. All right, so what I want you to do is I want you to work on the IXL that is posted underneath this video and give it a try. Good luck.